Welcome to the revision video for experimental research methods. Experimental methods are taught in cognitive psychology. So on paper 1 at A level, these can appear specifically in relation to cognitive psychology as a topic. They're also quite likely to appear in paper 2 attached to criminal psychology, where we use different experimental methods to test eyewitness testimony in particular, and also jury decision making. And of course, they can also come up in the unseen material on paper 3. So we're going to recap through some of the background information on laboratory, field and natural experiments. If you remember, these are specifically focused around the manipulation and measurement of IVs and DVs. So it's important to remember and be able to identify from example studies the independent variable. So this is the variable that is manipulated by the researcher, and the dependent variable is the variable that is measured by the researcher. So one handy little task is to go back through all the pieces of supporting evidence and your classic and contemporary studies and see if you can identify what the independent variable was and also what the dependent variable was that was measured. This is quite a common task on paper 1, 2 and 3, to be able to identify both of these from unseen scenarios and also be able to put these into a hypothesis, which we'll look at in a minute. One of the processes that is really important when it comes to IVs and DVs is the operationalization of each of these variables. So this is the process by which you make sure that your independent variable and your dependent variable are shown to be very, very, very specific. Right? So if you are manipulating word lists, for example, you don't just say words. Right, you need to say how many words are in the list. So it might be something like a list of 20 acoustically similar words, or it may be that you use 15 nonsense trigrams. So you've got to be very, very clear. And the same for the dependent variable. Quite often the dependent variable is the number of correctly recalled words or trigrams in cognitive psychology, but it can be any other measure. So if you think about Milgram, for example, in social, his measure of the dependent variable was the level of voltage out of 450 that participants went up to. So it's very, very important to make sure that those variables are really, really, really clear. And that is extremely important for when you put them into a hypothesis as well. So when it comes to hypotheses, you have two different types, if you remember. So you've got your experimental hypothesis. So this is the statement of the aims that you intend to find out. So you've got an example there on the screen. Students will recall significantly more on a Monday morning than on a Friday afternoon. Any difference in the DV will be due to the IV. So this is a little bit of an activity that I want you to have a think about as well as we go through this slide. So let's say we're testing words from a list of 10. How would you operationalize those variables? All right, so your independent variable is Monday and Friday. That's done for you, but what is the DV? So recall is not enough. So how would you make that really, really specific to say a list of 10 words or a list of 10 trigrams? All right, so have a go at just improving that experimental hypothesis, and do the same for the null hypothesis. So remember, the null hypothesis is the one that you would actually test. When it comes to falsification, it is much easier to disprove something 95% certainty than it is to actually prove something to 95% certainty, because there will always be, when you're testing humans, some element of chance, some element of an anomaly. So you always convert your hypothesis into a null hypothesis, which is the bit in red. So you would add no significant difference to the one above and make the statement that any difference will be due to chance. Right? And then when you actually test that null hypothesis and you do your stats test and your probability, usually we do 0.05, that will give you 95% certainty. And if it comes out as significant, therefore you can reject your null hypothesis. Just to add into that, the experimental hypothesis is the term that is used for a hypothesis attached to an experimental method, so a lab, a field, or a natural experiment. If you're doing a different type of research method, so for example a closed questionnaire or a structured observation, you would call it an alternative hypothesis. This is purely because it uses an alternative method. Right, so there's nothing overly complicated, but it is useful if you see on an exam, write an alternative hypothesis. They're not asking for a null, they are asking for a hypothesis. It's just that it's not an experimental method that's in the scenario. So when it comes to the nature of hypotheses, if you remember, we've got two different options. So if something has substantial evidence behind it, there's been other research and you're fairly confident that you know which way your results are going to go, you would do a one-tailed hypothesis. So you would predict the direction of the results. This refers to when you are making statements that males will show less empathy than females. Monday morning, students will recall more words than Friday afternoon, things like that. So when you're saying something is more or less, bigger or smaller, quicker or slower, anything that says what you are specifically predicting the outcome to be. And again, you tend to use one-tailed hypotheses if you have a solid pilot study or there is existing research. So for example, like the cognitive practical, where you've done recall of trigrams based on lots of historical research about short-term memory duration and capacity, you'd be fairly confident to give a one-tailed hypothesis. If you are less confident, so perhaps you are doing a pilot study, perhaps you are looking at a new area of memory where there hasn't been quite a substantial chunk of research, or you're just not quite sure that there's going to be a difference. So for example, if you're doing something about the difference between male and female recall of words, and you don't really know which way it's going to go, you would do what we call a two-tailed hypothesis. So this is a statement that there's going to be a difference between the two measures of the DV. So there's going to be a difference between males and females. There's going to be a difference between Monday and Tuesday. There's going to be a difference between empathy and having no empathy, but you don't really know whether that's going to be a particular way. So you just know there's going to be some sort of difference, but you're not sure whether males or females will be more or less, bigger, smaller, quicker, slower, and so on. So we use what we call a non-directional two-tailed hypothesis. So you're accepting that there's going to be some sort of cause and effect, but you don't really know which way that cause and effect is going to go. So the experimental method does try to establish quite strict controls over the different factors that might have an unwanted effect on your dependent variable, because the only thing you want to be testing is the effect of the independent variable and what it does or what changes it causes on the dependent variable. So enabling you to make cause and effect statements, you must be really, really certain that the only thing affecting your DV is your own manipulation of the IV. Now, in a laboratory experiment, this control is quite easy to establish. Field experiments, you can control a little bit, but not quite as much. And in a natural experiment, you're unable to control those variables at all, although you still have independent and dependent variables, but your independent variable is obviously naturally occurring. Control over those unwanted factors is really, really important. In your planning of any experiment, those other variables that you need to control are known as extraneous variables, extraneous being external. So anything that could potentially impact on your dependent variable. You plan out your controls and the ways in which you're going to make sure that you don't have any unwanted effects, but sometimes an extraneous variable does influence your dependent variable, something that you didn't predict, something that you weren't aware of, and so on. If it does influence your measure, so your dependent variable, it then becomes known as a confounding variable. So it has confounded the results, it has confounded your measures, and therefore your results are not a statement of cause and effect between your IV and DV. So extraneous variables you try and control. If you don't manage to control them all, they then become a confounding variable on the actual data that you've gathered. So the variables that you do actually have control over are obviously your independent variable and your measure of the dependent variable. So what we need to know is that these are constant, and particularly in a lab experiment, this is really important for your reliability because it means that you can retest your data to check your findings for accuracy and consider your test of your independent variable as reliable. So Badley is a good example. He made sure that each word was shown to each of the participants for the exact same time. And this is something that's consistent across a number of cognitive experiments. The time exposed to the stimulus, so the word, the trigram, timed interference tasks, activities and things like that, everything is very much controlled. So those factors that are kept constant are called your controlled variables. And one of the major advantages of a lab experiment is that different situational variables can also be controlled. Now, situational variables are probably best highlighted by Milgram, who intentionally manipulated different situational variables to test the effect on obedience. So his baseline measure 5 was very much controlled in a lab context with an authority figure in Yale University, but then he manipulated the situational variables. So his IV and DV remain the same. The authority figure giving the instructions, DV, how far the participants went up the scale of electric shock, but he manipulated those situational variables. So run down office block, using a telephone, so proximity to give the instructions, and using an ordinary man to give the orders. So you can manipulate situational variables if it is important to test different situational influences on your experiment. It's not done quite so much in cognitive because there's not usually a need to do it, but Milgram and obedience is a really good example of how situational variables are manipulated if needed. So in cognitive psychology, you do tend to keep the situation as constant as possible for each and every participant. So that can be everything from noise, in particular in cognitive. Don't just talk about controlling noise in every experiment in the world because it's not necessarily an issue. In cognitive psychology, it is because noise will obviously act as an interference task. Things like temperature, that can cause people to become sleepy, tired, less focused. So again, it can have an influence on memory. It can also have an influence on lab experiments into aggression. If you become quite hot and the temperature in the room is quite stiflingly hot, you become more aggressive and things like that. Because all of these situational variables are kept constant, it could lead to what we call demand characteristics. So this is where participants may be able to guess the aim of the study that they are in, and therefore by showing demand characteristics they may behave in a different manner to how they normally would. So having such really strict controls can actually make it quite obvious what is being tested, and therefore that does have an influence on the behaviour of participants in some situations. To try and counter that, you can use your single and double blind procedures. Single blind is when participants definitely don't know the aim, and you try to make sure that when you're getting consent you give them something similar to what you might be looking for but not actually the truth. So again, Milgram is a good example of this, although he's not cognitive psychology, where he told them he was testing learning, which seemed like what his experiment might be about, but obviously he was really testing obedience. So trying to prevent them guessing the real aim by giving them an aim that's similar enough so that they can, don't have to try and guess really what they're actually doing. Double blind is similar, so participants as well go through single blind, they don't know the aim, but you get a different research to conduct your study, so you are not influencing the outcome of your results at all. You've got somebody else doing it. They don't know what the aim is. They're just given a set of instructions and they're told to do this, this, this and this and measure this. So, you know, it might be read some words out, ask them to count backwards, count the number of words they recall, right? And the researcher is not told what they're looking for either, and that prevents researcher bias and prevents that experimental effect, giving subtle hints, body language, facial expressions that might clue the participants into guessing the aim. So the first of your 3 experimental methods is your laboratory experiment. This is used quite a lot in psychology. You'll see lab experiments across every single one of the topics that we look at. Again, this is likely to come up as a specific question in cognitive psychology on paper 1, a specific question on paper 2 in relation to criminal psychology, where things like eyewitness testimony, so Loftus and Palmer, I know you've had a look at that, and other studies have taken place to test things like eyewitness testimony. And again, it's highly likely to come up on paper 3, where you get unseen materials, unseen studies, and you'll have to use your understanding of a lab experiment to pick those apart and identify different features, IV, DV, hypothesis, strengths, weaknesses, improvements and things like that. So the key thing about a lab experiment is that it takes place in a non-natural artificial setting for the participants, right? So it's not necessarily just in some sort of science lab thing. It is because it's artificial for participants. So for example, if you are doing a test of chemistry students, you would take them out of a chemistry lab and do it somewhere else. Otherwise, that is a familiar context. If you're testing the recall of students, which was done by Sebastian Hernandez-Gil, they tested the children's school. They took them out of the classroom, which is normal for them, where they're used to learning, and they tested them in an office in the school setting, which was an unnatural, artificial setting for those children. So as we said, laboratory experiments take place in a very set of controlled conditions. The independent variable is manipulated by the researcher in a particular way to see if this causes any effect on the dependent variable, which is what they measure. So, for example, you may have specialist equipment in a room, so that might be Milgram's voltage machine. You may have a specialist task, so things like the different word lists that badly used, acoustic similar, dissimilar, and semantic similar, dissimilar, and so on. A laboratory experiment will therefore have very highly standardised controls and procedures. This makes it incredibly straightforward for a lab experiment to be replicated. And remember, replication is what allows you to test for reliability. So you're testing whether your results can be reliably achieved over and over and over again, which gives those results reliability. So one of the common ways to structure a lab experiment is to make sure that you've got an experimental group, which is the IV manipulation that you want to test, and a control group. So when you think about your independent variable, you will always have 2 different aspects to that independent variable. Whenever you're asked an exam question about this, you must therefore give both conditions of an independent variable. So for Badley, that was acoustically similar and acoustically dissimilar words, right? Acoustically dissimilar being your control group for short-term memory, acoustically similar being your experimental group to see if acoustic similarity had an effect on short-term memory. So you must always give both aspects of the independent variable. The control group will provide what we call a baseline measure. So this allows you to see what would happen to the dependent variable if you didn't manipulate anything, right? So you've got your baseline measure. This is what happens in sort of this very straightforward, for example, when there's acoustic dissimilarity, this is what we can do with our short-term memory. And then you bring in your experimental condition. So what happens if the words are acoustically similar? Then you can see what that does to short-term memory. You can't make a judgment about the effect of the independent variable on a dependent variable without a baseline control. If you don't know what normal memory is, or you know, normal obedience, or you know, normal conditioning, behaviour, anything, then you cannot make a judgment about whether your experimental condition had any effect or not, because you don't know what you're judging it against. So that's why it's really important to put both aspects of an independent variable in there. Examples, you've got Milgram, Sebastian Fernandez-Gill and Baddeley. These are specific examples of lab methods that you have done. As you go through the course, you will obviously be able to add more and more lab experiments to these examples. Again, remember, if this question is asked in paper 1, it is in relation to cognitive psychology, and you cannot use any other example other than cognitive psychology experiments. So it might be worth going back through your notes and jotting down a few additional examples of a lab experiment, just to give you those wider resources to draw from. So, strengths of a lab experiment. They allow you to identify a cause and effect relationship between the independent and dependent variable. So any change in the dependent variable is due to the independent variable and not due to chance. This gives you very strong scientific credibility in any piece of research that has taken place using a laboratory structure. Because you can give that cause and effect relationship, and it's so well controlled, it can be reliably retested, and it gives it very strong internal construct validity, right? You can be very sure that what you are testing is what you set out to test. And by having those really strong controls over extraneous variables, it allows you to make sure that there is no other effect of a confounding variable on your dependent variable results. This allows reliability to be increased. It's strong internal reliability because of the scientific structure, but it also means that you can retest your experiment over and over just to check the accuracy and consistency in the results that you've got, and make sure that it is a reliable piece of evidence that your independent variable did in fact change your dependent variable. So as we've mentioned, it allows reliability because you can test and retest your findings. This again links to scientific credibility within a lab experiment. Thinking about your Graves evaluations, it will give you that S of supporting evidence because you can repeat particular studies. So for example, if you're looking at Milgram and his baseline measure, Berger's replication of Milgram, that gives Milgram and Berger strong reliability because Berger was able to retest to a certain extent Milgram's findings. As we've said, lab experiments have high internal construct validity. You are more certain that what you are doing, so the manipulation of your IV, is the only thing that is changing your dependent variable that you're measuring. So you can be more certain that you are undertaking a true and real test of cause and effect. You're more certain that your results from the dependent variable that you've measured are a real, true reflection of just the independent variable and not any confounding variables. In terms of weakness, obviously the more controlled and strict and artificial a situation is, whilst the reliability goes up, validity will always go down. So experiments lack, first of all, ecological validity because they take place in that non-natural and artificial context for the participants. You must get that bit in there. It's an unrealistic setting, an unrealistic context. So remember, ecological refers to the situation in which somebody's in, not the task, that's task validity, but refers to the environment, the eco structure of the experiment, the actual environment in which they are doing the particular study. In a number of experiments, though, total control over every variable is not always possible. You won't be able to control how the participants are feeling that day. So if you're doing a memory test, for example, if a couple of those participants didn't have a good night's sleep, that's not something you can control. They may be more tired, they may be slow responses, they may recall less, and therefore it is a confounding variable. And depending on the number of confounding variables or the types of confounding variables that you weren't able to control, it can reduce the internal reliability. Also, lab experiments are also not suitable for certain kinds of research. Milgram, again, I know he's not cognitive, but he's a really good example of research that wouldn't ever be replicated in that particular way. There are many other unethical experiments that you wouldn't ever conduct, you know, depriving children of emotional responses to see how it affects their attachment and likelihood of criminal behaviour. You're not going to be doing that. Things like in learning theory, we look at media violence. You wouldn't do a lab experiment where you exposed children to excessive media violence to see if they then developed violent behaviours in adulthood. So there are a number of situations where lab experiments are not suitable for your investigation. In cognitive psychology, it tends to be that lab experiments are used quite a lot because there aren't that many unethical implications of memory tests, recalling words, numbers, and things like that. So this tends to be something that you may want to sort of hold on to for evaluating the use of lab experiments when we look at some of the other studies further on in the course. Again, because of the artificial nature of tasks, task validity is often quite weak, particularly in cognitive psychology. Using digit spans, word lists, and so on is not something that you would do on a daily basis. So it's quite difficult. For example, if you look at Peterson and the recall of trigrams, and obviously we did that for our cognitive practical, this isn't something you do on a day-to-day basis. Nobody's ever going to ask you to learn sets of random trigrams for any purpose whatsoever. So that lack of task validity means it doesn't represent how memory would generally work. Participants will obviously be aware that they are in a lab experiment because of the controls, the nature, the artificiality, the structure, and so on. And that can increase demand characteristics, even if you use single blind and double blind techniques to try and control those. It is likely that they will at least know and understand that they're in some sort of test environment, and therefore they will quite often try harder, particularly children. So Sebastian Fernandez-Gill is a good example of this. The children would have wanted, particularly at a young age, to please the researchers, so they'll have tried really, really hard because they would have known they were in some sort of memory test. And quite often there is low generalizability. Again, the experiment is artificial, doesn't represent day-to-day tasks. It doesn't sort of generalize itself to real-life contexts, to real-life situations. And it also lacks generalizability because you tend to have an unrepresentative sample. It'd be very difficult to do a lab experiment where you have got the ability to test even a stratified sample representing the wider population, because lab experiments can be quite time consuming and expensive to set up. So you generally end up with students, because they're quite often done in university research, and they don't represent the wider population. So that brings you to field experiments. Field experiments are carried out in a more natural setting, so something that takes place in the field. So it's more natural for the participants. They may still have a manipulated task, they may still have some element of control over certain conditions, and the researcher is still responsible for manipulating the independent variable and measuring the effect on a dependent variable. So in the field may include testing students in a classroom for their memory skills. It may be that you are testing waiters and waitresses in a restaurant to see how many items of food they can recall without writing them down. Those kinds of situations where you would test somebody's memory in a context in which they would normally be. So whilst you can control a number of the extraneous variables in a field experiment, so for example, if you're doing tests of children in a classroom, you can put a little sign on the door to say, please do not disturb. You can't control all of the variables, particularly if you're doing something that is more out in the open. For example, waiter or waitress in a restaurant, you can't control whether somebody interrupts that person before they get from the table to the kitchen to place the order and things like that. So they do become slightly less reliable than a lab experiment, but your counter point to that is that as something becomes less reliable, it tends to become more valid. Sheriff's Robbers Cave study is one that we'll do in social psychology. It's the classic study. He used a field experiment where the boys were in a summer camp. This is natural for American teenage boys. They often go to summer camps. So it was conducted within a field, although he did manipulate particular variables that took place in that study. So advantages of field experiment, they can still identify cause and effect because you are still manipulating an independent variable and you are still measuring its effect on the dependent variable. They are conducted in a more natural surroundings, so it may be more generalizable to real life in the sense that you're likely to have a more representative sample of people within that situation. So if you go back to the waiter and waitress in a cafe or restaurant, you'd be able to generalize your results to a wider population of waiters and waitresses in restaurants and cafes because you are testing them within their specific environment. It does also have more ecological validity because it is generally done in a setting that is more contextual and therefore less controlled and artificial. So it's a bit more reflective of real life. There's highly unlikely to be experimental bias, so experimental expectations would be reduced, and demand characteristics tend to be lower as well because you're not as aware that you're actually in an experiment because the artificial setting has sort of been removed from that, and it does therefore allow experiments to take place whereby you may not even be sharing the aim. Now that does lead to ethical concerns, but if you're testing, for example, children's memory, you may well set up a field experiment that is part and parcel of their normal day-to-day learning. So you might get, I don't know, year 5 children to learn a list of spellings, which is something that they would do all the time. So you wouldn't necessarily be asking them for permission. So there are ethical downsides to field experiments. So because of your lack of control over extraneous variables, you are more likely to find that there are some confounding variables that are affecting your results, and that your measure of the DV could be influenced by external factors that you either could not control or did not predict. So, you know, if you're testing someone's memory, cafe, restaurant, like I said, if somebody wanders up and starts a conversation, that is an extraneous variable that you weren't able to prevent, becomes a confounding variable because that person is highly unlikely to remember the food order. So it does reduce the reliability because you can't retest the exact same environment, the exact same events, and the exact same extraneous variables. So there is a reduction in reliability because they're much more difficult to undertake replications. Field experiments can as well be more time consuming and expensive than a lab experiment because you're going to have to go to the environment. You may have to transport equipment to particular environments. You may have to go through various gatekeepers for access. So if you're going to research memory in a school, you're going to have to speak to the school, the teachers, the head, the parents, all that in order to set it up in the first place. So it can take an awful lot more time and money as well as you're going through those processes. So as I mentioned, ethical issues obviously become a problem if you're not letting people know that you're undertaking a field experiment with them. It reduces your ability to gain informed consent. It reduces your ability for debriefing. So for example, if you're doing a field experiment where you're just kind of watching what happens if you set something up in, I don't know, a shopping centre, where you want to see what happens if I don't know, somebody falls over. Say you're looking at bystander effect in social psychology, you can't necessarily get hold of all the people and the passers-by that were there at the time to debrief them and ask them for retrospective consent. So that may be a bit of an issue. And sampling techniques tend to be a bit biased as well. It's often opportunity sampling because you just need to be able to access whoever happens to be within the field environment at the time you're doing your research. Depending on what you're doing and when you're doing it, this can be limited to particular groups of people. So for example, if you're doing a study in the middle of the day, you're highly unlikely to get a wide range of the population. You're going to find that you're predominantly sampling through opportunities people who don't work, so perhaps retired individuals, people who are unemployed or at home with childcare responsibilities, things like that. You're not going to get a wide range of people who may be in school, university, or in work in the middle of the day. So it's only those that are available when it's taking place. Therefore, generalisability to the wider population is limited, it becomes reduced, and your study overall lacks population validity because it is not a representation of everybody who would be in that potential environment at different times of the day. So your third and final type of experiment is what we call a natural experiment. Now, natural experiments are quite a rare occurrence. There's not an awful lot of them that have taken place in psychology. But there are one or two. Now, it generally wouldn't take place in cognitive psychology. However, there are some in criminal and also in social learning theory, where natural experiments happen to have taken place. So a natural experiment, again, is in the field, so to speak, so it's in a naturalistic setting, but the independent variable is naturally occurring. So it is something that it happens to take place, where psychologists can get out there and measure the effect on a particular dependent variable. So at the moment, that might include, for example, the effectiveness of online learning and recorded videos. So due to the COVID pandemic, there has been a massive surge, ironically, in recorded videos like this, where teachers are stuck in quarantine. And as a result, a lot more students have been using recorded or online live lessons to access their learning. Now, this is not something that you could set up either as a lab experiment or as a field experiment. It would be unethical to do it for either of those options. So it is something that could never, ever, ever have been tested until this point in time. So that independent variable of online remote recorded learning can be compared against the baseline control of previous learning, where everybody was lucky enough to have face-to-face all the time. And that's what we mean by a naturally occurring independent variable, something that suddenly takes place where people are able to jump in and do research. So some of the advantages of a natural experiment: you can still identify cause and effect relationships because you are still measuring the effect of an independent variable on a dependent variable. So even though that IV is naturally occurring, you can still measure what happens as a result of it. It allows you to test situations, as I said, that would be impossible for a researcher to actually have created, either because it is something that is unethical, or it is something, for example, the switch to online remote learning, it is something that you just simply would not have been able to do on such a wide scale. So natural experiments are therefore conducted not only in a more natural surrounding, but also with a natural event that's taking place, allows it to be generalizable in terms of the representativeness of the sample and the people involved. They are the people actually involved. Therefore, for example, the sample of students who have undertaken online education, they represent students of online education. They are, so your results will be generalizable to that population that experienced that naturally occurring independent variable. They are more ecologically valid because it's real life, natural context, natural situation, and so on. It's not manipulated and controlled and artificial. There wouldn't be any experimenter bias, so the experimenters wouldn't necessarily have any expectations, not only because the participants are not aware that they're in an experiment, but also because the researchers are not directly manipulating anything themselves. They are actually just sort of jumping in and assessing and testing the effect of particular independent variables on what they're measuring. So it's not something that they have structured in a way to suit their expectations. Demand characteristics are likely to be very, very low because, again, the participants don't know they're in an experiment, they don't know what the aim is, they don't really know that it is taking place. This, if it helps, is a really good example of where you would use a two-tailed, non-directional hypothesis. So if you're looking at the effects of online education on achievement, that is something that's never been tested before. You've never done a pilot study on that before, so that would be where you would sort of be talking about using a two-tailed, non-directional hypothesis, because there isn't an existing base of research to enable you to do a one-tailed hypothesis. So this is a good example of where that would take place. However, in a similar way to field experiments, you can't control your extraneous variables, right? So there could be a whole multitude of different things that will be affecting the outcome of that dependent variable. Distractions, noise. If you are looking at that online learning kind of hypothesis, you know, access to broadband computers, internet connections, whether the internet's gone down in the middle of a lesson, all those different things you would be completely unable to control, and you would have quite a significant number of extraneous variables in those sort of natural occurring situations that would become confounding variables and confound your data. Therefore, reliability is reduced because you cannot be certain that you have a scientifically credible test of the effect of the IV on the DV, and also you can't retest your results in that way. Natural experiments are quite expensive and very time consuming. Again, similar to the field, you're going into the environment, you're transporting equipment, that costs time and money. And in addition, because it's so almost unexpected, I suppose, that expense can go through the roof because you've got to, so you can't plan it well in advance. You've got to kind of like jump on something when it actually takes place. So that can result in lots of sudden unexpected expenses, even from paying research support staff right through to buying in lots of equipment and things like that. Okay, so the other research method that you cover in cognitive psychology is the method of case studies. So these are quite commonly used in cognitive psychology, and you do need to know the case study of HM in depth for your exam content. Case studies are the complete opposite of controlled experimental studies, and that's why they're sort of both taught in cognitive, so you've got direct opposites. You'll come up against case studies again in biological. You look at case studies of brain damage and how that links to aggression. Cognitive is obviously brain damage and how that links to memory. And you will also come up against case studies in clinical psychology, and therefore it can come up on that paper. So it's really, really important that you understand the principles of case studies. One of the things you do need to remember when you're talking about them, depending on what section of paper 1 or 2 these have come up in, is that you must be specific to the topic area. So please, please, please don't talk about case studies in terms of, you know, HM, oh, it helps us understand how the brain works. That's not what HM is about. So if case studies come up in cognitive on paper 1, you are to talk about how case studies of brain damaged patients help you understand memory and specify memory. It's not to do with brain function, it's memory. In biological psychology, it's to do with aggression, brain functioning and brain structure. In clinical, it's to do with very specific mental health disorders. Predominantly, we tie these in to OCD. And if it comes up on paper 3, it will be tied into whatever unseen scenario material that you've got. So please, please, please remember to be really specific about what the case studies are actually looking at. So case studies are qualitative. So they provide detailed descriptions of findings in written extended depth. You can use what we call triangulation. So within a case study, you can do an experiment. So like HM, it documented in depth, in detail, all his medical history, his notes, observations, a few experiments on his memory ability and so on. So you can use lots of different methods within a case study to pull together that actual case overall. So in cognitive psychology specifically, this focuses on how brain damaged patients can lead to memory dysfunction. So in HM, it was obviously the loss of transference and forming new long-term memories. You've got Ostergaard's 10-year-old boy in Tulving, so being able to form different types of memories, but remember it must always be focused on memory in cognitive psychology. You have gone through and done a little activity already that's drawn together some examples of case studies. So these 3 are familiar. It may be helpful for you to recap on that. Make sure you've got as many case studies down as you possibly can. That will help you with not only any questions on the case study method, but also will help you in reverse to talk about supporting evidence and evaluating particularly HM, which you can be asked a direct question on for 8 marks all by himself. Right? The others you can't, but HM is named on the spec, so you do need to know that in sufficient detail. So that brings us to the evaluation skills and exam skills and how methodological questions would appear across the different papers. Okay, so this is a more general question. Explain one strength and one weakness of using a laboratory experiment in psychological research. So this could come up more generally towards paper 3 content, really. It's likely that this will be tied in to a scenario. If it is tied into a scenario, it becomes AO2 and you must link your strength and weakness to the scenario. But if it's given in a general form, then your AO1 and AO3 might look as it is on screen. So I've gone away from using cognitive psychology just to show how you can make these connections across the course. So slightly different in terms of using Graves when you're talking about a method compared to when you're evaluating a study. So if you think about the structure of your study evaluations, where you give the good point or the bad point that is from the study, so you're very, very specific, and then you link it for AO3 to the type of generalized type of Graves, how and why it is a strength or a weakness. Evaluating methods is kind of in reverse. So your AO1 is your understanding of the strength or the weakness in this case. And that is quite generic. It is the bit about what it is about a lab experiment that gives you reliability. All right, so standardized procedure, which means it can be replicated, which increases the reliability. So there you go, you have a strength. Your AO3 is to justify how we know that this is a strength. So where has somebody used it? And if you look at the question, it's this bit here. All right. How and where has somebody used this in psychological research? All right. So Milgram used a standardized procedure. Exactly what he did. So don't forget, you still have to be specific. So what did he standardize? And why was it reliable? Because it was a reliable test of obedience. So you've got to make that connection in the AO3. As opposed to in the AO1 like you would for a study, right? This question can come up in a number of different ways. So this bit here at the end, the psychological research bit, that could say one strength, one weakness of using a lab experiment in cognitive psychology. And if it comes up with the in cognitive psychology, then this example here, right, it needs to be from cognitive. Badly, Sebastian Hernandez-Gil, they're the two default ones that I would suggest you go to. If it says in biological psychology or social psychology or learning theories or clinical or criminal, which is quite likely, again, you must use a piece of research that has come from the area that they specify. So when you're doing essay planning, so this could come up on paper 1 as an 8 marker, and it can only come up as an 8 marker in cognitive. Okay. Further down the line, when we get to criminal, it can come up as a maximum of a 16 marker. All right. So we will look at that when we get there in year 13, but it is worth making sure that you can pick out quite significant AO1 strengths and weaknesses now, because there's nothing extra in terms of AO1 that you'll cover for a 16 marker. The emphasis becomes on the AO3 and your connections to criminal research. So in terms of your AO1, you need to plan this out now, in depth and lots of detail. All right. So you need to talk about what it is about the method and the structure of the method and the way in which it is conducted, right, that allows you to talk about generalizability. So you can talk about the reduction in being able to test a wide and representative sample. So lab experiment findings are generally lack generalizability because you have limited samples available. They have increased reliability. All right. And again, what is it about a lab experiment that is reliable? So the control of extraneous variables, cause and effects, scientific credibility gives you reliability, and so on. Application, if you can do it. Again, this is a more general methods question. So application, you'd probably find much more straightforward for case study evaluations, perhaps not so much for a lab experiment. Validity, break it down into the 3 different types. When you get to year 13, there are more, and if you are revisiting this video in year 13, remember you can link this to things like your concurrent validity and so on that we do in clinical. Ethical issues, what might they be? Can you get past them? I mean, obviously with a lab experiment you can actually gain quite detailed, fully informed consent, but again, further down the line, that's going to affect demand characteristics and so on. Sampling, you are able to do a stratified sample, you're able to do a volunteer sample, unlikely to use an opportunity sample for a lab, but you might for a field and a natural. what are the good and bad points of those tied into this particular method. Design, you can talk about how in a lab experiment you can basically come up with that design yourself. So if you wanted to do independent measures to reduce demand characteristics, so 2 separate groups, or you could do repeated measures to reduce the impact of individual differences in the participant variables. Talk about how both of those can be done in a lab experiment and how that is beneficial, why they are strengths, why they are weaknesses, what's good and bad about them, and make sure that you are always tying these points back to the method that you've been asked about. So in this case, a lab experiment. So yeah, AO3 has got to exemplify and justify how you know that the points you've made for AO1 are in fact a strength or a weakness. How do you know that a lab experiment in cognitive psychology has good reliability? How do you know that? You've got to tell the examiner that you understand how that actually works within that field of psychology, in this case, cognitive. So you've given me a strength or a weakness, linked it into the method and Graves. You then need to back it up. Every single statement must be backed up. So reliability, this is good because blah, blah, blah. Badly did this. And this is how I know that reliability is a strength in cognitive lab experiments, right? Peterson and Peterson, they did this. This is how I know that construct validity is a strength, but ecological validity is not a strength. Whichever way you are going, you must support every point that you say for strength and weakness in your AO1. You can also do that in a more sort of general sense and build that in, but please don't do the whole thing quite generically. You've got to put in some examples of laboratory experiments in this particular question. But you can use things like tasks. If you're talking about task validity being artificial, lack of validity, blah, blah, blah for your weakness, you could talk about how in cognitive psychology we tend to do tasks that include word lists or digit spans. And these are not necessarily representative of real life tasks and so on, all right? But don't go too much into that side of things. You can do it, but make sure you've got a substantial chunk of actual research studies in there as well. So once you've had a go at an essay plan for laboratory methods in cognitive psychology, you can have a go at doing the same question for case studies. So again, this is something that comes up in clinical. We do look at a little bit more detail about case studies, and it also comes up in biological. So these will become quite familiar. But the same thing, so have a go at maybe planning out at some point an 8-mark essay for case studies in cognitive, an 8-mark essay for case studies in biological, 8-mark essay for case studies in criminal, and 16 would be a bit much, but it's not impossible, and also in clinical. Don't worry too much about those. If you're recapping on this in year 13, we'll do that together anyway. So you can also have a go at doing the same for field and natural experiments. Now, you won't have sets of examples of these for cognitive psychology. It's not something that's commonly done. So in terms of the bringing in the field and the natural experiments, this is more likely to be paper 1, 8-mark question, or paper 2, criminal, 16-mark question that asks you about the experimental method overall. And when it says experimental method rather than laboratory experiment, it means all three, right? So if you're going to have a go at planning a question, planning an essay answer for field and natural, please do that in the sense of experimental method in general. So you would need to bring in all three and have examples of all three. And we will tackle that again in criminal because we do a few more field and natural experiments when we look at eyewitness testimony and jury decision making. So that brings you to the end of your experimental methods revision session. You can recap on this at any point, have a go at some of those questions, try and pull together and keep going back to your methods over and over and over. The better you understand your methods, the stronger your evaluations will be on studies, and also the easier it will get to apply plausibility and credibility to your evaluations of theories as well. Any queries, please just drop me an email or post a message on Teams, and give me a shout if you need anything else.